Okay, so this is the second video on implicit differentiation. The problems in this video will be more complicated. There will be more product rules or quotient rules in here, and we're going to be doing some second derivatives. So please take careful notes in your notebook and make sure that you add to it from what you read. Okay, so just to review how to find derivatives implicitly, you are going to be differentiating both sides of your equation with respect to x. Tomorrow we will actually start using t as our differentiation variable, but for now we'll just keep with x. Then you're going to collect all terms with dy dx's to one side of the equal sign. Again, I usually move mine to the left side of the equal sign and all the other terms to the right. Then you factor out dy dx, and you're going to solve for dy dx. Okay, so this first problem is to find dy dx implicitly, and just to give you an idea of what some of these graphs look like, I put a picture here. This is called a lemniscate, and obviously it's going to be impossible to separate x and y's from one another, so we're going to be doing implicit differentiation to do this. So we're going to start by taking the derivative of both sides of the equal sign. So 3x squared plus y squared squared, and then the derivative of 100 times x squared minus y squared. So when we differentiate this left side, we're going to have a chain rule going on here. So we're going to bring this guy down. So we're going to have 6 and then x squared plus y squared times the derivative of the inside, which is 2x plus 2y dy dx. And this will equal the derivative of the other side. So on the other side, we could just bring the 100 out. So it's going to be 100 times 2x minus 2y dy dx. Remember, every time we take the derivative of y, we have to include a chain rule here. Okay, so this next piece, I will start distributing things together. We're going to have distributing this entire thing into the set of parentheses. We are going to have 12x times x squared plus y squared plus 12y dy dx times x squared plus y squared. And this whole thing will equal 200x minus 200y dy dx. Sorry, that ran off the page a little bit. And then we're going to start piecing more stuff together. I'm going to have a 12x cubed plus 12x y squared plus 12x squared. Oops, x squared, y squared. Y dy dx plus 12y cubed by dx equals 200x minus 200y dy dx. So now it's time to get all my dy dx's together. So this term is going to stay on the left, this is going to stay on the left, and that's going to move to the left. So I will have 12x squared y dy dx plus 12y cubed dy dx plus 200y dy dx equals, and then we're going to move these guys to the other side of the equal sign. So equals 200x minus 12x cubed minus 12x y squared. The next step is going to be to factor out our dy dx. So we have dy dx times 12x squared y plus 12y cubed plus 200y equals 200x plus 12x cubed minus 12x y squared. And then our last step will be to remove this, solve for dy dx. So we're going to divide everything by 12x squared y plus 12y cubed plus 200y. So our final answer over here would be dy dx equals 200x minus 12x cubed minus 12xy squared all over 12x squared y plus 12y cubed plus 200y. And we could actually go through and see if there's anything that divides evenly. All of these are divisible by 4, so it could divide out of 4 and actually have 50x minus 3x cubed minus 3xy squared all over 3x squared y plus 3y cubed plus 50y. Okay, so this problem is slightly different. This one wants to know the second derivative of the function. So d squared y dx squared, that just means find the second derivative. So we're going to start this problem the same. We're going to go ahead and implicitly find the first derivative. So I'm going to take the derivative with respect to x of everything in this equation. So we're going to have 2x plus 2y dy dx equals 0. So moving stuff around, we're going to move the 2x to the other side of the equal sign, and we're going to end up with 2y dy dx is negative 2x, and then solving for our dy dx, divided by 2y, we end up with our first derivative is negative x over y. So now we're going to find the second derivative. So we are going to take the derivative of this function. And what happens is our second the derivative of the derivative is the second derivative, so this side is d squared y dx squared. I'm sorry about that. And this other side will become a product rule. I mean a quotient rule. I apologize, a quotient rule. So we are going to use low d high, so the low function is y. The derivative of the high function is negative 1 minus the high function, which is negative x. The derivative of the low function is dy dx. All over the low function squared. So kind of putting this together a little bit more neatly, we would have our second derivative is equal to negative y plus x times dy dx all over y squared. So we're going to take this dy dx, we actually know what that value is. That value is negative x over y. So I'm going to substitute that here. Let me erase this here just so I have room to do the substitution. We're substituting this into this equation. So we have our second derivative is negative y plus x times negative x over y all over y squared. So if I wanted to put this whole numerator together, this would right now say negative y, not plus, it's going to be minus. So minus x squared over y, all over y squared. So what I'm going to do now is multiply this function over here by a y and a y to get a common denominator. So I'll have negative y squared minus x squared over y, all over y squared. And so finally, we're going to put our denominators together, and we end up with negative y squared minus x squared all over y to the third. And that would be our second derivative for that function. Okay, and then our last problem is going to be to find the tangent line of a graph at a point radical 2 over 2, radical 2 over 2. So you have a couple options. I think I'm going to distribute this x squared to begin with. You could actually just do the product rule right off the bat, but I think my life will be a little easier if I distribute that. So what I'm going to start with is the derivative here. So we're going to take the derivative of everything. So this will become 4x to the third plus, and we do have to do the product rule for this middle one. So I'm going to split it up over here. It's x squared and y squared. X squared is 2x, y squared is 2y, dy dx. So combining them together, these guys go together, and these guys go together. So we have a 2x y squared plus 2y x squared dy dx. We'd probably rewrite that. And then that equals 2y dy dx. So our next goal is get all your dy dx's together. So we end up with 2x squared y dy dx minus 2y dy dx equals negative 4x cubed minus 2x y squared. And then we're going to factor out dy dx. I'm going to take these out. And that equals negative 4x cubed minus 2x y squared. And our last step is to solve for dy dx. So it is negative 4x cubed minus 2x y squared all over 2x squared y minus 2y. And if I wanted to simplify this a little bit, I could divide everything by 2. Everything's divisible by 2, so it becomes negative 2x cubed minus x y squared all over x squared y minus y.